First step is to create a new project or to open an already existing project. In this case, we create a project called Guide Example. We can also create packages to pack sets of Petri nets. In this case, we create a package named Move. Inside this package, we create a Petri net named GoToPoint. The next step is to create the different elements of the Petri net and program commands and events. In this case, we first add all the places, then all the transitions, and finally we link places and transitions. Changing labels for places and transitions is a good programming policy in order to make the Petri net clearer. Global variables can be used to receive parameters, set values, and also test them. For this example, we define two variables to receive the goal coordinates. One is named xpos, the second is named ypos. Running parameters are associated to variables by name. Next, we select the command and event programming tool. Clicking on a place, we can see all different possible commands. Most of them correspond to modules installed in the system. For this place, the set goal message of Navigator module should be published. The set goal message has two parameters that are the goal coordinates. We could assign constant or variable values in this case. For the x-coordinate, we associate the xpos global variable. For the y-coordinate, we associate the ypos global variable. The condition associated to next transition is the arrival of a message with a valid path. This message should be published by Navigator in order to test for a valid path. We are going to check that the path length message field has to be greater than 1. The command associated to the next place is to follow the planned path. This is commanded by sending the message go to Navigator. This message has no parameters associated. The goal reached transition is fired when the robot reaches the goal. Therefore, the message autonomous stopped is associated. We also check that the reason to stop is that the robot in fact reached the goal, which verifies the reason to stop. This is the basic Petri net, but we should also take into account that different problems can occur. For example, the robot can stop because the goal is unreachable or because it has some problems. Therefore, the Petri net can end for different reasons. We can return different values. When the Petri net ends, the dispatch sends a message with a parameter that is the return value. We can also time some parts of the Petri net using a timer. In this example, we define a timer named reach goal timer to time the follow path action.